This is chapter 2, number 85. We're going to drop a rock off a cliff, and then the sound has to travel back to us for us to actually hear the splash. Let's look at the rock first. The rock is dropped, so it's going to be modeled by h equals 1/2 gt squared. Well, let's call that t1. They do tell us in the problem that the total time, which we can call t1 plus t2, equals 2.4 seconds. Going back up, the sound is going to travel the certain distance h, going the velocity, which they told us the speed of sound, in t2. So the velocity of the speed of sound is going to be 336 meters per second. So if you think about it, we have three equations and three variables. We have an equation that relates h with t1, h with t2, and then we have a relationship between those two variables. So what I'm going to do is I'm going to take this and solve for t1, so multiply both sides by 2, and then divide by g and take a square root. So 2h over g represents t1, and over here we get h over our speed of sound, 336, equals t2. At this point, I'm just going to do a substitution. Into the original stipulation, it says that the total trip was 2.4 seconds. So then I have 2h over g plus h over 336 equals 2.4. And realistically, at this point, the physics is done, and now it's just math. I'm going to get my calculator out, and I'm going to solve this. Probably would graph this as y1 and graph 2.4 as y2 and find the intersection point. What you're going to do is you're going to find that the height is 26.4 meters. The second part of the problem asks you to compare what happens if you ignore sound. Well, if you ignore a sound, the fact that the sound actually has to travel back up to your ears for you to hear the splash, you would treat that the 2.4 seconds was the total fall. So in case number 2, it's certainly still modeled by 1/2 gt squared. But to find the height, we're going to use 1/2 9.8 times 2.4. And that gives us a height of 28.2. The error calculation is just looking at what we got, 28.2 versus what it is, dividing by the actual value itself. And that gets us like 0.068, which leads us to somewhere around a 6.8% error.